Question number 1. Consider the following systems of linear inequalities. Which of the following ordered pairs are solutions to the system? Remember, in order for a coordinate point to be a solution, it has to satisfy both of the inequalities, okay? So we've got two inequalities here. We've got this top one and this bottom one. And what we're going to do is we're going to plug in each one of these coordinate points into that. Now, this can be quite time consuming considering that there are 7 equations, so I've already done the work for you. I just want you to follow along as I express and show you what I've done. Alright, let me go ahead and move this out of the way and remove that. Now, if you look at this right here, what I did was I wrote down each equation or each inequality. Alright, so I first started out with this one right here. And then x plus 2y is greater than or equal to 10. And then I wrote 3x minus 4y is greater than 12 right here. Now what I'm going to do is, because each coordinate point is x comma y, I'm going to replace each xy with the coordinate point. So in number 1, 16 and 9. In number 2, I'm going to replace it with 10 and 2, 8 and 1, and so on and so forth. Alright, so let me go ahead and eliminate that real quick. Alright, so if you look at the first one, now this one went ahead and worked out. When I plugged in the 16 right here and the 9 right here, it came out to 16 plus 8, which is 34, and 34 is definitely greater than or equal to 10, so I put a check mark right there. On the right hand side, I plugged in a 16 right here and a 9 right here. 3 times 16 is 48, 4 times 9 is 36, so the result is 12. Because 48 minus 36 is 12. Now, 12 is greater than 12. That is not true. 12 is equal to 12. So that's why I put an X here. And that is false. And that's what you're going to do and go down the line doing the same thing to all of these. So let's go ahead and check out which ones are solutions. So if you look at the first one, 16,9 is not a solution because it doesn't satisfy both of them. 10,2 satisfies this side, and it also satisfies this side. So you know what? 10,2 is a solution. If you look at 8,1, 8,1 also satisfies it, and so 8,1 is also a solution. Let's go ahead and move this up a little bit further. And 2,6, if we look at 2,6, 2,6, I just did the right-hand side here, and I got negative 18 is greater than 12. That is false, so therefore it is not a solution. 4, negative 4, I only had to do one of them, and negative 4 is not greater than or equal to 10, so that is not a solution. Remember, it has to satisfy both inequalities. 14,1, 12 is greater than or equal to 10, and 46 is greater than or equal to, or greater than 12, so 14, negative 1 is a solution. And then finally, the last one, negative 4 and 2. Well, as you can see, this did not satisfy the inequality, so therefore it is not a solution. Problem number 2. Select the inequalities represented by the graph below. Select all that apply. On this particular graph, they gave you the y-intercept, which is c. Now remember, we're going to use y equals mx plus b. Now in this case, b is our y-intercept. They are using the letter c, so we're just going to replace that with the letter c. Okay? So we're going to replace that with letter c. Now what we want to do is we want to find the slope. Now it might be a little difficult to do, but if you can guess that 1 is about right, negative 1 is about right there, and go straight up to that line right there, that is about, if you go from 1 up 1, that's about 2.5, and over 1, that it's a rise of 2 and a run of negative 1. So that slope is going to be negative, or 2 over negative 1, which is really just negative 2. So we have a slope of negative 2. I'm going to replace m with that slope. So now I have negative 2. Now, if you notice, every one of my answers over here have a 2x and a y and a c. So I'm going to go ahead and I'm going to look for things that look very familiar to this. Now, if you look down the line, if you look at y equals negative 2x plus c, you notice that this one is exactly the same. Now, there's a little problem here. Let's look for the inequality. Now, notice I've told my kids in the past that whenever you're shading, okay, you start at the y-intercept. Well, if you start at the y-intercept and notice that the shading is going up the y-axis, that means all the numbers that are greater than or equal to C. So I'm going to go ahead and replace this right here. So we're talking about all the y's that are greater than or equal to C. That's how I usually figure out what my inequality is. So in this case, this one is exactly like the graph that I'm using. Now, you could manipulate some things. Now notice that these three have C by itself. All right, now it did say check all that apply. So what I'm going to do right here is I'm going to take that equation, y is greater than or equal to, or this inequality, and then I'm going to add 2x to both sides. And what I end up getting is 2x, bring down my plus, I'm going to go ahead and add the y, is greater than or equal to C. And if you notice, that one looks just like one of our answers, which is 2x plus y is greater than or equal to C. And there's our other answer. Question number 3. A student government organization is selling Christmas trees as a fundraiser. On Friday, they sold 5 noble fir trees and 3 Douglas fir trees for a total of $420. So what I could do is since I'm going to let N equal noble and D equal Douglas. So 5N, 5 noble trees, plus 3 Douglas fir trees gave me a total of $420. Then, on Saturday, we sold 12 noble trees plus 9 Douglas fir trees, and we got a total of $1,080. Now, if you notice, we have a system, and there's a couple of ways we can manipulate this or solve for this system. Now, the method I'm going to choose is elimination. And the first thing I notice is that I see that I can eliminate these D's right here because 3 goes into 9. All right. So what I'm going to do is I'm going to multiply this top one by -3. And what ends up happening is I have to distribute that -3. So what happens is I get a -15n minus 9n. And then you even have to multiply by the 420. So you get a -1260. Now, I'm not doing anything with this one right here, with the second one, so I'm going to just write it over here, plus 9D. Oh, that was supposed to be a D, wasn't it? Let me go back and change that. That's supposed to be a D, not an N. Now, one of the things I can do is I'm going to add straight down. This eliminates to give me -3N. These two are opposites, so they eliminate. And then I get -1260 plus 1080 gives me 180. Then I'm going to divide by -3. I take that back, that's a -180. And so when I divide by -3, the -3's cancel out. I get N is equal to +60. Now remember, N is our noble fir tree, so that means it costs $60 to get a noble fir tree. Now I need to find out how much it's going to cost for a Douglas fir tree. So I'm just going to use the information I have, and I'm going to go back to plugging this in. So I'm going to choose either equation. It doesn't matter. I'm going to choose this one right here because it's smaller. So I'm going to plug in 60 for N. So 5 times 60 plus 3 times D equals 420. This is 300 plus the 3D equals 420. I'm going to subtract 300, and I get 3D is equal to 120. When I divide by 3, 120 divided by 3, and I get D is equal to 40. Therefore, a Douglas fir tree cost $40. So $60 for a noble fir tree and $40 for a Douglas. Question number 4. Beverages Incorporated sells espresso for $8.50 per pound and roasted coffee for $10.25 per pound. The following equations represent a recent online purchase. Now, which of the following is true of the purchases? Now notice they're not asking you to do actually any work. They're actually just for you to identify the equations. So now I want you to notice something. I want you to notice that this 8.5 went with the X. Well, up here, the espresso was assigned the $8.50. So that means X is going to be our espresso. All right, so sometimes it's best to just write this information down. And if you notice, since 1025 belongs to the Y, that means that's our roasted coffee, because 1025 goes with roasted coffee. So Y is equal to roasted coffee. All right, now, I want you to notice a few things. When you look at some of these equations, okay? So notice here, it says that X plus Y, let me get a different color here, X plus Y is equal to 5. Well, what that's saying is that when you add the espresso and the roasted beans to get coffee together, you've bought 5 pounds. So it's $8.50 for every pound of espresso and $10.25 for every pound of roasted. So let's look at some of the answer choices that they gave us. Okay. A, the variable X represents the pounds of roasted coffee in the $46 purchase. Well, no, X represents the espresso. Okay, so that's obviously wrong. We know that the Y represents the roasted coffee. So you know what? That is true. So B so far is our correct answer. But let's go ahead and go further. I want to make sure that the other two are not possible. The consumer spent $46 and purchased 5 pounds of espresso. No, they bought 5 pounds of both, this right here, of both espresso and roasted. So C is wrong. And then same thing with D. The consumer spent $46 and purchased 5 pounds of roasted coffee. Again, they bought 5 pounds of both coffees combined. Question number 5. The following ordered pairs are solutions to a linear equation. Which of the following graphs show all of the ordered pairs in the solution set of this linear equation? Okay. Now, sometimes you can do just minimal work and get the answer. All right. Now, notice all of these graphs. I'm not sure if I can blow this up a little bit. If you look at these, it starts really low. So if you look at like right here, it goes 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 5. Well, none of these numbers are as big as the points that they've given us. And that's true for all the graphs. Okay? So if you look at these, and you might want to look closely, look at this one here. Look at the numbers. None of those numbers match in any of these up here. Okay? So what we're going to do is we're going to take our coordinate points and we're going to see what kind of slope, because obviously the graphs deal with positive and negative slopes. So maybe we can eliminate some of the answers that way. All right, so let's look at the first one. Let's go ahead and make a T-chart. We're going to go ahead and put negative 20 here, 11.5 here, negative 21 and 12, and negative 22 and 12.5. Now, if you look at these are all increasing by negative 1. So 20 to 21 is, from negative 20 to negative 21 is negative 1. Over here, going the same direction, these are both increasing by 0.5. Now, if you remember, slope is change in y over change in x. Oops, sorry. That's supposed to be an x there. Or y2 minus y1 over x2 minus x1. So use either one of those. Well, I'm going to go ahead and use delta y over delta x. And what I'm going to do is I'm going to pick out my ratio. Well, the ratio in this case is 0.5 over negative 1. Well, 0.5 divided by 1 is actually 1/2. And negative 1, so that's going to be a negative 1/2. So you need a slope that's negative. Well, there's a couple of things. This is a positive slope. This is a positive slope. So I've already eliminated 2 of my answer choices. So now I have a 50-50 chance of getting it right. Now, notice your slope. Your slope is negative 1 over 2. That means it's a rise of 1 and a run of 2. So if you go up 1, that means you have to go left 2. Or if you go down 1, you have to go right 2. Okay? One of them has to be negative. So let's take a look at this first one. If I start right here, and I go, well, let's blow that up. Let's start right here at the x-axis. If I go up 1 and to the left 2, I meet the line. Well, let's try this one at 1. If I go up 1 and to the left 2, I'm over here in the negatives. Well, that didn't work out. So I know that's not the answer. Therefore, this first one is my true answer. Okay, at number 6, which of the following equations has the same solutions as the equation 3x plus 2y equals negative 12? Now, what we're going to do is we're going to take 3x plus 2y equals negative 12, and we're going to manipulate to try and test and see if I can get each one of these equations. Okay, so that is your job, is to go ahead and manipulate this equation. Well, I've already done the work for you, and I'm going to go ahead and show you the answers. The answers that I've gotten are the second one, the third one, and then these 2 right here. Okay, everyone else is not a solution, and I'm going to show you why they're not a solution. So we have 4 solutions and 3 that are not. Okay, here we go. The first one, if you notice what I've done, let me go ahead and minimize. Let me go ahead and get rid of those. Kind of push this off to the side. Now, if you notice what I've done, this first one, in order to get 3x, I multiplied by 1 here. Let me go ahead and change that color to black. I multiplied by 1. 1 times 3 is 3x, and that checks out. But when I do 1 times 2, I'm supposed to get 2y, not negative 2y. So that was wrong. That's why the first one is not an answer. Okay, let's look at the second one. In order to get from 3x to negative 3x, we're going to multiply by negative 1. So that means I have to multiply everything by negative 1. Okay, so negative 1 times 3x is negative 3x, so that checks out. Negative 1 times 2y is negative 2y. And negative 1 times negative 12 is a positive 12. So that checks out. That's why the second one is an answer. So let me go ahead and move this off to the side. That's why this one right here is not an answer, and this one is an answer. Okay, so let me go ahead and move that back over here. Bring this back. Now we're going to check the rest of these. So let's look at these real quick. This first one, in order to get from 3x to 15x, we're going to multiply this by 5. So 5 times 3x is 15x. That works. 5 times 2y is 10y. And 5 times negative 12 is a negative 60. Well, you know what? This is a solution. Let's go ahead and go to the next one. In order to get from 3x to 6x, we need to multiply this whole thing by, you guessed it, 2. 2 times 3 is 6x. That checks out. 2 times 2y is supposed to be 4y. Well, that is wrong. So that's not a solution. All right, we're going to move on to the next couple, the last 3. All right, let me go ahead and change the color here. All right, now on this one right here, in order to get from 3x to 6x, we need to multiply by 2. 2 times 3x is 6x. 2 times 2y is 4y. And 2 times negative 12 is negative 24. So that is also a solution. Now, this next one's a little tricky. How do you go from 3 to 1.5? And how do you go from 2 to 1? And from negative 12 to negative 6? Well, if you guess that you multiply everything by 1/2 or you divide everything in half, you are correct. Half of 3 is 1.5. Half of 2 is 1. Half of negative 12 is negative 6, and therefore that is a solution. And then finally the last one, in order to get from 3x to 1x, we have to multiply by 1/3. Remember, multiply by the reciprocal gets you back down to 1. So if I distribute this, 1/3 of 3 is 1. 1/3 times 2 is 2/3. But if you take 1/3 times negative 12, well, 3 goes into 12 4 times. So this should have been a negative 4, and that is simply not the case. And that is why the last one is not an answer. Moving this back. So therefore, your answers are these 4 problems. Okay? Juan visited a candy store and purchased 7 pounds of candy consisting of atomic fireballs and gummy bears. Atomic fireballs are $4.25, the gummy bears are $1.25, and Juan spent a total of $14.75. Alright, so whenever you're doing this problem, we also want to know which of the following graphically represents this situation. Now, you could probably spend all day doing this one problem, but let's go ahead and cut to the chase. We know that the atomic fireballs are X, the gummy bears are going to be Y, and when I add these together, I've gotten 7 pounds. Now, I know that the atomic fireballs are $4.25. I also know that the gummy bears are on sale for $1.25 for every pound of gummy bears. And I'm going to spend, or Juan's going to spend, $14.75. Now, one of the things you might have been taught to do is to plug in zeros for X and 0 for Y. So if you look at your graphs, here, all right, each one of these graphs has a Y and X intercept. Well, I could find the intersection by using a calculator or using substitution or elimination, but let's take an easier route. What I'm going to do is I'm going to plug in 0 for X, and then I'm going to plug in 0 for Y and solve for the other variable. And this is what you're going to do. So if I plug in 0 for X, that basically means 4.25 times 0 is basically 0. And what you're left with is $1.25. Y is equal to 14.75. Well, I'm going to figure out what Y is. And when I divide by 1.25, I get approximately Y is equal to 11.8, which is really close to 12. So let's kind of guesstimate. So when X is 0, Y is going to be close to 12. Okay? Now, after I've done all that work, let's go ahead and take a look at all this work that I've done. Let's take a look at these pictures. Okay? Now, first things first. We know that the atomic fireballs are our X values. Well, if you notice, I can go ahead and eliminate these two equations, or these two graphs, because gummy bears are on the X-axis and they're supposed to be on the Y-axis. Okay? Now, if you look at the bottom two, atomic fireballs are on the X-axis, so that's a good thing. Now, we just found out that this equation right here is at 0.12. Well, of the two equations, there's only one that's close to 0.12 or 11.8. That is this one. So I can go ahead and eliminate this graph, and this one is my answer, just by process of elimination. Earlyn owns French Twist Hair Salon. She charges $35 for a cut and $120 for a cut and a color combo. Okay, yesterday she had 7 clients and earned $500. Now, it doesn't say what they had. It just says she has 7 clients. So we know that we had X is going to represent those who get a cut, and Y is going to represent those who get a combo. So if I add up the clients, I know that she had 7 clients yesterday. Now, we also know that it's $35 for just a cut, and it's $120 for the combo. And she made $500 yesterday. Okay? Now, which of the following equations could be used to represent this situation? And check all that apply. Well, if you notice, X plus 7, or X plus Y equals 7, is not one of the equations. Okay? Now, Let's go ahead and try to manipulate something. Let's take this one for instance. If I take x plus y equals 7 and I subtract x from both sides, I end up getting y is equal to 7 minus x, which is just like this first one. So that first one is possibility. Just by moving variables around or numbers around, we can make it look like some of these others. Now, notice that the second one is x plus y equals 500. Well, we know that's not true because 35 times x plus 120y is equal to 500. So we can go ahead and eliminate that one. Now, notice that this particular one, I'm going to go ahead and erase that line right there. Okay. Now, look at this one. This is the exact same equation as this one, except these two are switched around. Now, you might say to yourself, well, that can't be right. They can't be switched. However, if you were to switch these two around, oops, sorry about that. If you were to switch these around and assign x to the combo and y to just the cut, then yeah, that could work. So you know what? This is actually a possibility because that's all it's asking for. Which of the equations could be used? And if you switch the value of x and y, or not the value, but if you switch the x to be a combo and y to be just a cut, then yeah, you could use this one. Okay? Or actually, you could use this one right here. So now we've got two possibilities. Let's check these other ones. On this one here, 35 plus 120 times x plus y. When you distribute that, you can't really combine both of those equations. Okay, you can't multiply this one times this one. So that's not an answer. And then the very last one has 35x plus 120y equals 500. It's exactly like this equation. So yeah, that is one of the answers. So I know I wrote all over this, but those are our three possible answers. Now in question number 9, a system of equations can be solved by elimination in the table below. Well, I want you to notice something. They take this first one and they multiply it by 2. And they didn't do anything to the second one. Then on the right hand side, they take the second one and they multiply it by 3. Okay, and they didn't do anything to the first one. So technically, if I eliminate those, I still have my top one and bottom one. Okay? Now, notice they went ahead and multiplied 2 times 5 is 10x, 2 times 3 is 6y, and then 2 times 14 is 28. So they're okay with that. Down at the bottom here, they did 3 times 4x is 12x, 3 times negative 2y is negative 6y, and 3 times negative 2 is negative 6. So again, the bottom one checks out. Well, what they ended up doing is they took this equation and this equation and they put them right here. So they combined those. And they want to know, does the system of equations on line 4 have the same solution set as the system of equations on line 1? They want to know, does it have the same solution set? Well, because they were consistent going down, you know, they manipulated the first one correctly, and they manipulated the second one correctly, and then they combined them here at the end. The answer is yes, they do. Okay, so let's go ahead and look at our answers here. I'm going to move that over here. Question A, the system of equations step 4 is equivalent to the system of equations. That is true. However, it says the systems do not have the same solution set. Well, that is false. That contradicts itself. So that is not the answer. So let's go ahead and move that out of the way. Let's look at B, C, and D. We can go ahead and eliminate B because it says it's not the answer, or it's not equivalent. And D does the same thing. Well, let's just make sure C is the correct answer. The system of equations is equivalent. That is true. And they have the same solution set. So C is our answer. Now, number 10, disregard the last 4 answers at the bottom of the page. And let's just look at this chart here. Consider the following system with the solution 1, 3. So that means 1, 3, if I were to plug 1, 3 into this, that would check out and this would check out. We want to prove that replacing the first equation with the sum of that equation and a multiple of the other produces a system with the same solution. So what we're going to do is we're going to make sure we're going to go through these steps right here, and at the very end, we're going to make sure that 1, 3 is a solution to this new system. But first, we want to make sure that they did the steps correctly. So let's go ahead and get that taken care of. Okay? Now, on this first one, equation 3, so we're going to make a new equation. Equation 3 is a multiple of equation 2. So let's look at equation 2. Okay, here's equation 2. X minus 2y equals negative 5. And the new equation 3 is 2x minus 4y equals negative 10. Well, if you notice, we talked about this earlier. What did they do to this equation to get to this equation? Well, if you say they multiplied by 2, you would be correct. 2 times x is 2x. 2 times negative 2y is negative 4y. And 2 times negative 5 is negative 10. So you know what? This equation right here is correct. So let's go ahead and eliminate that. Okay, now, what we're going to do, so that checks out. So let's move this up a little bit. Now, look at equation number 4. Equation number 4 says you're going to add, or the sum of equation 1 and 3. Well, equation 1, if you recall, is 2x plus y is equal to 5. And equation number 3, which is this one right here, is 2x minus 4y equals negative 10. So it wants the sum right here. So we're going to add these. Let's go ahead and add them down. 2x plus 2x is 4x. Y plus a negative 4y is a negative 3y. And 5 plus negative 10 is negative 5. And if you notice, that's the exact same thing that they got. So you know what? That checks out as well. So now we have these two new equations. We have 4x minus 3y equals negative 5 as our equation 4. And then we have x minus 2y equals negative 5 is our equation 3. Now the last thing is we want to make sure that 1, 3 is a solution to the new system just as it's a solution to the old system. So let's go ahead and plug in the number 1 for x and 3 for y. So 4 times 1 minus 3 times 3 is equal to negative 5. Let's check that out. So that's 4 minus 9 equals negative 5. And sure enough, negative 5 does equal negative 5. And so that one checks out. Now, in order for it to be a solution, they both have to check out. So I'm going to go ahead and plug in a 1 minus 2 times 3 equals negative 5. So 1 minus 6 equals negative 5. And sure enough, negative 5 equals negative 5. That also checks out, so we can safely say that 1, 3 is a solution to the new system.